Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem permutation in string. In this problem, we are given with two strings S1 and S2 and we have to return true if S2 contains permutation of S1 or false otherwise. In other words, return true if one of S1's permutation is a substring of S2. So we have to check if S2 contains any permutation of S1 or not. If it contains, we have to return true. If it doesn't contain, we have to return false. So in this case, we are given with S1 as AB and S2 as some string, and we have to check if permutation of AB exists in S2. So S1 is AB. So what are the permutations of AB? One is AB and other one is BA. Permutation is nothing but rearranging the characters in the string to form a new string with the same characters. So if we see in this S2, we are having the substring BA, which is the permutation of S1. So we have BA is the permutation of S1. So we have BA over here. So we return true. And again, we are given with the string S1. And this time, if we see here, if we observe, there is no AB or BA over here. We don't have continuous string AB or BA. So we return false. What are the constraints? The length of the string can be at most 10 power 4 and we will be given with lowercase English letters. So let's see how we can solve the problem. Before solving the actual problem, let us see how we can find if one string is a permutation of other string or not. Let me take an example. A, B, C, C and the other string as C, B, A, C. So we can tell both strings are permutation, but how we can find it programmatically? What we can do is we can have a hash map. We can have a hash map which keep tracks of frequency of characters. So in this case, we iterate over the string and we record the frequencies of each character. So A is repeated one time, B is repeated one time, and C is repeated two times. So this is the hash map of the first string. And the hash map of second string will be C is repeated two times and B is repeated one time, and then we have A is repeated one time. So we iterate over the string and we keep incrementing the frequencies. So we can see both the hash maps have same values. We know that the hash maps are unordered, so we only consider key value pairs. All the key value pairs are equal. So we can say both the hash maps are equal and both strings are permutations of each other. So in this way, we can find if two strings are permutation or not. Now let us solve the actual problem. So in the first example, we are given with S1 as EAB and S2 as EIDBAOOO. Okay. So what we can do, what will be the naive or the brute force approach? Let me write down the second string AOOO. What is the naive or the brute force way of solving the problem? So we can start at each index. At each index, we can consider the length of S1. Okay, we can consider the length of S1 at each position and we can see if this string is a permutation of S1 or not. We check if EI is permutation or S1 or not by the method which we have discussed previously. So EI is not a permutation of AB. So now we move to I and we check if ID is a permutation of AB or not. It is not, so we move, and we check DB is a permutation of AB or not. It is not, so we move on, and we check BA is a permutation of AB or not. It is, so we return true. In this way, we can find the solution. What will be the time complexity of this approach? At each position, we are going till length S1. So we are if we take the length of S2 as n and the length of S1 as m, so at each position O of n into we are going through m values, so it will be O of m. So O of n into m will be the time complexity. And what will be the space complexity? We are using the hash map. So we are using two hash maps each time of length m to keep track of frequency of the characters present in the substring, and in the S1. So it will be of O of M. So this is the time and space complexity. Can we reduce that? So if you know the sliding window pattern, we can apply the sliding window pattern whenever we have to find something in a continuous subarray or a substring or a sublist. So here we have to find something in a continuous subarray. So if we have to find if continuous subarray is a permutation of the given string or not. So we can apply the sliding window approach. So let's see how we can apply the sliding window approach. So we have the string 2 as E, I, D, B, A, O, O, O. And we have the S1 string as A, P. This is S1 and this is S2. Okay. So what we do in sliding window approach is so in previously we are checking this string and then we are moving this and then we are moving to here. We are checking in this way, but there is some recomputation over here. If suppose the length of S1 is AB only, what if the length of S1 is some 5 characters? Then we check this, then we check this, and then we check this, and then we check this string. So if you see, if you clearly observe, there is a recomputation over here, right? We are recomputing this portion of the substring in this window and as well as this window. So to avoid recomputation, we use sliding window approach. In sliding window approach, it is very simple. It is almost similar to the previous approach, but instead of taking the entire string from here, what we do is we move the window by one step. How do we do that? So in the previous approach, we have this window and we calculate the frequency map of this window and we calculate the frequency map of S1 and we check if both are equal or not. All right, let me take the frequency map of S1. So in this case, let us take some other string as S1 because AB is very small. So let me take S1 as some A, P, and D. Okay. So what will be the hash map for S1? A, we have ones, B, we have ones, and D, we have ones. So this is the hash map for S1. So now we take 3 characters from the first position and we create a second hash map. So we iterate over here. So E will be 1, I will be 1, D's frequency will be 1. So we check if both the hash maps are equal or not. They are not equal. So now what we do is, instead of recomputing this entire string, we slide this window by one step. Now what we have done is we have added this to our window and we have removed E from our window. So we have added this and we have removed this. So we do the same thing in our hash map as well. We remove E from our hash map because E's frequency is 1. We decrement E's frequency and E's frequency will become 0. We do not keep the elements with frequency, keys with frequency 0 in our hash map. So we simply remove it. And then what we do, we add the B to our hash map. We add B and its frequency will be 1. Now we check again if these two hash maps are equal or not. They are not. So now we again move our window by one step. In this case, what we have done, we have removed I and we have added A. So same we do over here. We decrement the I's frequency to 0. So 0, the frequency is 0. So we remove it from our hash map and then we add A to our hash map. So we add A. Now if we see, both the hash maps are equal. We have A equal to 1 and B equal to 1 and D equal to 1. So we have found a match, a permutation in our S2. So we return true. We return true. What will be the time complexity of this approach? What we are basically doing over here, we are iterating over the string only once. We are just moving the window each time, and we are adding and deleting elements into our hash map. So what will be the time complexity? Since we are iterating over our string only once, the time complexity will be O of n. What will be the space complexity? We are using two hash maps, which will be at most of length O of m. So the space complexity will be of O of m. What we have done here, we have reduced the space complexity from O of n into m to O of n. So this is the sliding window approach. Let's code it up. Let's start by calculating length of both strings, n equal to s2 dot size and m equal to s1 dot size. And then we have to keep track of frequencies of the characters in s1. So let's consider a map. Character integer, let's name it map1, and we iterate over the string s1, and we add the characters to our map1 of c plus plus. And now what we do, we should have another map to keep track of substrings, frequency of characters in our substring in s2, character int, and let's name this map2. And now we iterate over the second string, and we add the character map2 s2 of I, the character present at the ith position of our, we add the character in s2 to our string. And if we have more than m characters in our string, that means we are moving the window. In case we are moving the window, we have to remove the previous value. So m2 of s2 of I minus m, we remove this and we check if map2 of s2 of I minus m is this equal to 0. If this is equal to 0, we remove or erase that character from our map s2 of I minus m. Next, we check if the current window's map is equal to our s1 map. So s map 1 equal to map 2. If this is the case, we found a permutation. So we return true. If we iterate over the entire string and we haven't found any permutation, then we return false. Looks good to me. Let us run the code. It passed all the sample test cases. Let us submit it. It passed all the test cases. So as discussed, the time complexity of the approach, sliding window approach, is O of n, and space complexity is O of m. So I hope you have understood today's problem. I have made an entire series on sliding window pattern. So if you want to practice sliding window problems, make sure you check that series. I will link it in the I button. That's all for today's video. I hope you understood the video. If you did, make sure you hit that like button and subscribe to Coding Charms for more daily videos. Till the next video, keep practicing. Take care. Bye bye.